All right, guys, so lesson 1.4, graphing trig functions. Today's lesson is more about the properties of the graphs, and then in class, we're going to get to actually drawing the graphs. So let's get cooking. Let's talk about graphing trig functions. So here's some information about the domain and range of these different trig functions. So we're just going to run through why this is true real quick. So domain, sine and cosine, all real numbers. You can input anything into sine and cosine. It'll give you out some value. But that value, the range will be between -1 and 1. This makes sense because if you think about the unit circle has a radius of 1, which means if it's centered at the origin, that was a terrible, terrible line. But if it's centered at the origin, that was even worse, but we're going to live with it. Centered at the origin, the largest the x value you can get is 1, the smallest you can get is -1. Same thing with the y value. So sine and cosine both have a maximum of 1 and a minimum of -1. So tangent, the domain, the input can be all real numbers except odd integer multiples of pi over 2. The reason for that is tangent is sine divided by cosine, and I can't divide by cosine if cosine is 0. So cosine is 0 at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, and so on and so forth. Anytime that cosine is 0, tangent is undefined. And if I notice, remember, cosine is the reciprocal of secant. Secant is 1 divided by cosine, so secant has the same domain as tangent because these are undefined when cosine is equal to 0. The range of tangent is all real numbers. The short explanation for this is because there's an infinite number of values between -1 and 1, and less specifically, I guess, there's also an infinite number of values from 0 to 1. So any quotient, tangent is sine divided by cosine, we can write any real number as a quotient of real numbers between 0 and 1. So tangent's range is all real numbers, and for the same reason, cotangent's range is also all real numbers. So cosecant and cotangent, if you notice, they have the same domain. It's all real numbers except integer multiples of pi. The reason for that is cosecant, remember, is the reciprocal of sine. So 1 over sine is undefined when sine is 0, and sine is 0 at pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Anytime that I hit the x-axis, sine is 0. So cosecant, which is 1 over sine, is undefined, and cotangent, which is cosine divided by sine, is also undefined at those multiples. So the last thing to talk about is the range of cosecant and secant. It's all real numbers greater than or equal to 1 or less than or equal to -1. The reason for that is cosecant and secant are reciprocals of 1 over cosine and 1 over sine. If cosine and sine always output a value between -1 and 1, the largest their absolute value will be is 1, and the smallest their absolute value will be is 0, which means if I do 1 divided by any number with an absolute value between 0 and 1, it will give me something larger with an absolute value larger than 1. So it's only numbers greater than or equal to 1 or less than or equal to -1. So we're going to run through just a few things that will also help us with drawing the graph. So first is the periodic properties of these functions. So sine, cosine, cosecant, and secant have a period of 2 pi. What the period means is it's the amount of time before the graph restarts, and it does the same thing again. And it makes sense when you think about the unit circle. There are 2 pi radians in the unit circle, which means after 2 pi, they'll start to repeat what they had done the first time. So tangent and cotangent have a period of pi. When we look at the unit circle, the tangent and cotangent values right here, up in the upper half of the unit circle, will repeat when you get into the bottom half of the unit circle. And that has to do with the quadrants that these values are located in. So then, speaking of which, the signs of the different quadrants, just think about it like this. First quadrant, everything's positive because both the x and y coordinates are positive. Second coordinate, sine and cosecant are positive, everything else is negative because the x coordinate is negative, which means the cosine is negative, which means the secant is negative, and if one of them is negative and the other one is positive, the tangent and cotangent must be negative. In the third quadrant, tangent and cotangent are positive because it's a negative value divided by a negative value, Everything else is negative because both the x and y coordinates are negative. The fourth quadrant, cosine is positive, secant is positive because the x coordinate is positive. Everything else is negative. This is negative because the y coordinate is negative, and these are negative because it's a quotient of a negative and a positive number. And then here is just a little table that you can draw for yourself that shows you when these different values are positive or negative. Really, if you remember the definition of these functions and you know which quadrant you're in, you can figure out if they're positive or negative by thinking about the x and y coordinates of the point. So helping to draw the graph will also be even and odd properties. So if you remember from algebra 2, a function is even if f of negative x is equal to f of x, or in this case, f of negative theta is equal to f of theta. So when we look at all of these different trig functions, this applies to cosine. So this applies here to cosine. And it also applies to secant, which makes sense because secant is the reciprocal of cosine. So our even trig functions are cosine and secant, and our odd trig functions are all the rest, because with all the rest we see that f of negative theta is equal to negative f of theta. So the reason that this helps when it comes to drawing the graph is even functions have reflectional symmetry across the y-axis, and odd functions have rotational symmetry around the origin, which means this is going to help me when drawing the graph, because if I can draw just the first and fourth quadrants of cosine and secant, I can reflect it over the y-axis and draw the rest. And with the odd trig functions, if I can draw one portion of the graph on one side of the origin, then I can rotate it around the origin to get the other side of the graph. So we're going to look at each of the graphs. In class, we're going to actually draw some of these graphs. But really, basically, what I want you to do is take a look at these pages. And we've kind of talked about all these things and why they make sense. We didn't talk about x-intercepts, but x-intercepts happen, or the x-intercepts are negative 2 pi, negative pi, 0 pi, blah, blah, blah. And those happen when the output is 0, which in each one of these cases, the output of sine is 0. The y-intercept is 0 because when I have a value of 0, when I have an angle with a measure of 0, the y value on the unit circle is 0. So the y-intercept is 0. And then everything else we've already kind of talked about why it makes sense. So the sine curve starts at 0, 0, goes up to a maximum of 1 at pi over 2, goes down to a minimum of negative 1 at 3 pi over 2, and then at 2 pi is back to 0. And then because of the periodic nature of it, repeats itself an infinite number of iterations. Cosine is actually this graph translated left or right pi over 2 units. So what I see here is this starts at 0, 1, and then it goes down to 0 at pi over 2, goes down to its minimum at negative 1 when I have a value of pi, and then goes all the way up to its maximum at 2 pi 1. And really this is same kind of idea as a sine graph. It's going to be periodic. It's going to repeat this curve over and over again. X-intercepts are these values this time because x-intercepts now occur when the x value is 0, which is at pi over 2, 3 pi over 2, negative pi over 2, so on and so forth, all of those values. And then we've also kind of talked about everything else here, the domain, the range. So really the rest of this is just going to be showing you examples of the graphs and what they look like. And then in class, we're going to actually draw and we're going to work with the graphs. And tangent function, so what actually happens with the tangent function is we have this right here, and then after an interval of pi, they'll actually repeat and do the same thing again. And I'm not very good at drawing, but you get the idea. So one thing that's a little bit different with the tangent function that did not occur in the sine and cosine graphs is there are vertical asymptotes in the tangent function. The reason for this is when we think back to when we talked about the domains of these functions, this domain does not include odd multiples of pi over 2, because whenever we have an odd multiple of pi over 2, tangent, which is sine over cosine, is trying to divide by 0 because at odd multiples of pi over 2, cosine is equal to 0, which means the function is undefined, which gives me a vertical asymptote on the graph. And then the rest of this we've already discussed. X-intercepts occur when sine is equal to 0 because tangent is sine divided by cosine. So these x-intercepts are the same x-intercepts that the sine graph has. All right, cotangent function. So all of the information is not displayed down here because we've gone through each of these now. Cotangent has vertical asymptotes in these locations at integer multiples of pi because cotangent is cosine over sine, and at integer multiples of pi, sine is equal to 0. Has a period of pi. It actually looks roughly like the tangent function, but it is the reciprocal of it. So this is the reciprocal, the graph of the reciprocal of tangent, basically. All right. Secant related to cosine. So if we notice right here, secant is the blue graph. It looks like a bunch of these little loops. So this also has vertical asymptotes, negative pi over 2, pi over 2, the odd integer multiples of pi over 2. Because secant is the reciprocal of cosine, and at those values, cosine is equal to 0. All right, now we've got sine and cosecant. Sine is the black function, cosecant is the blue function. Again, looks very similar to secant. So here's the secant graph, here's the cosine graph. They look like these little loops with vertical asymptotes. Again, the graph looks exactly the same, just translated left or right, pi over 2 units, because the vertical asymptotes are in different locations, because cosecant is 1 over sine instead of 1 over cosine, and these vertical asymptotes occur when sine is equal to 0. So, say we talked about the 6 graphs, the trig functions, the properties of each graph, domain, range, general idea of what they look like. So in class, what we're going to do is we're going to look at trig functions and other quadrants. So trig functions, all of those graphs that we looked at for the most part only showed either the first and fourth quadrant or the first, second, third, and fourth, but did not continue going after that. So in fact, let's change this to coterminal trig graphs or infinite trig graphs. What would these look like if they were to repeat infinitely? And then we're also going to draw the graphs and actually work with what they look like and how we create those graphs. So if you have any questions, hopefully you took some notes. You should have taken a lot of notes today. It was a lot of information. If you have any questions, I will be happy to answer them, and I will see you in class. Have a great day.